Hello, everyone. Welcome, and we're gonna wait for one more minute for the rest of the attendees to arrive, and we will kick off this session. Thank you. Okay, so we just broke the barrier of 100 attendees, and let's kick this off. Hello, and welcome everybody. Welcome to Quality Meets Speed in Digital Agriculture. This is a webinar hosted by Pix4D in partnership with our friends from Indigo and MyCasense. My name is Jorge Fernandez, and I'm the head of product for agriculture. And today I'll be your host. As you all know, crops change over time. And it is extremely important to understand that rhythm in order to make good decisions when it comes to input, water, and soil management. What we see today is that the weather conditions are changing so rapidly that we need to adapt to situations that we've never seen before. And we need to take advantage of all the data available in the farm. I'm very proud to introduce these three panelists today. And I think it's very unique that we have such a nice combination of software, hardware, and also actual use of this technology on a commercial setup. So today we have Nathan Stein from Pix4D. He will obviously talk about Pix4D fields and how we process images from cameras from MyCasense, where we have Drew Bastian, which will be running us through the basic requirements when it comes to data quality for MyCasense sensors. And then it's an honor to have Andrew Newsom from Indigo, who's running the sensor operations there, and he's been working with us on bringing this technology actually into the field and use it. And he's gonna blend everything together, and he's gonna help us understand how it's used. The agenda will start. I'm sorry, there was a small mistake on the agenda. It will start actually with Indigo, with Andrew talking about the Teraton initiative, and it will be followed by Drew talking about sensors and data quality requirements. Then Nathan will pick it up from there, talk about data processing and analysis and technology, and then Andrew again will wrap it up and show us how Indigo is using drones commercially. Then there's going to be a Q&A session where everybody, or we will try to answer everybody's questions. So do please post them on the questions section in GoToWebinar, and we will address them there. And without any overdue, I'll give the option to present to Andrew. And Andrew, you are ready to go.
All righty. Well, thank you for that introduction, Jorge. Sorry, having technical difficulties here. Okay. For some reason, when I start, there we go. So I just want to give you a brief introduction about what we do here at Indigo. So first of all, basically, we started off in 2014 as a beneficial ag company that works to basically use nature to help farmers become more sustainable. And we do this by focusing on farmer profitability and by improving sustainability of agriculture while also helping to provide a better agricultural product. Sorry guys, I'm having technical difficulties with my screens here. As previously stated, Indigo started out in 2014. We're now in 6 different countries. We've since raised over $700 million in funds. We also currently have over 1,100 employees. I think that number's actually off. I think we're closer to 1,300 at this point. And we work primarily in cotton, wheat, soybean, rice, and corn. And with that goal of feeding the world while also improving farmers' profitability, we found that we had to actually create a new system of agriculture, because the traditional system wouldn't actually work for what we were trying to do. So we had to create our own new system here, where basically we will partner with a grower or a farmer, and we will help them to better produce these crops by not only providing them support through our microbial technology, where we actually have microbial seed treatments, to where we put a symbiotic microbe with the plant to help reduce input costs, but we will also add in technology such as drones, weather stations, soil moisture sensors, and we will give all this technology, microbes, and the agronomic knowledge to our growers to help them better produce a superior product while also reducing the impact that they have on the environment. And so with all this growth and this superior product, we also looked at ways that we could help get these farmers to be more profitable. And the way that we found to do that is we founded our Indigo Marketplace, where we directly connect the producer to the end consumer, which gives the end consumer the ability to not only have traceability to where they can actually see exactly where their product is coming from, but they can also make demands on what they actually want from their product. So if they want a high protein wheat, they can put out a bid saying we need X amount of bushels of high protein wheat. Or if they want some really fine quality cotton, they can put that out, and they can also say how they want that product grown, and so they can get the exact product that they want directly from the consumer, or I'm sorry, from the producer. And then the producer also benefits from this direct interaction by becoming more profitable. And so we've launched several different projects and different branches to help make this goal true. But then probably the coolest project that we started using is the Teraton initiative that we launched back in June of 2019. And basically what the Teraton project is we are trying to take 1 trillion tons of carbon dioxide out of the atmosphere and into the soil by using a regenerative farming practice such as no-till or cover crops. And then also with this project, we are actually getting the farmers paid for their efforts. It's been really challenging for farmers to actually sell carbon credits, but we're actually, through Teraton, allowing producers to finally get paid for using these regenerative ag techniques. It's been really, really cool to see these farmers sign up. We've had a lot of interest in it. And if you have any interest in Teraton, please feel free to navigate to teraton.org to find out more information. And later on today in this webinar, I will go over some of the ways that we're actually using drones to start measuring the soil carbon. And with that, I'll turn it over to Drew from MicaSense.
Yeah, thanks, Andrew. So I'm going to cover the following 3 points over the next 10 or 15 minutes. I'm going to give you an introduction to MicaSense, And then we'll spend some time looking at multispectral imagery, some basics on multispectral imagery. It's probably going to be review for a number of the people in the audience. And then we'll look at radiometric calibration and the importance of radiometric calibration. And then I'll finish up by talking about a few MicaSense sensors that MicaSense develops and offers. So the way this all ties together is, MicaSense is producing the sensors, Pix4D is processing the data from those sensors, and then Indigo is going to show us how they're using those two combined to provide value to growers. MicaSense was founded also in 2014, so I guess Indigo and MicaSense share that characteristic. So we're headquartered in Seattle, Washington. We focus primarily on developing multispectral imaging hardware. So in the image on the right, it's kind of a fun picture I took last time I was in the office. It shows 4 renditions of the red edge. So the one nearest to you is the red edge 2. I couldn't find a red edge 1 because we only made 3 of them. So there were none of those laying around the office, but you can see how from the red edge 2 to the red edge 3 to the red edge M to most recently released red edge MX, farthest away, we've been improving the sensor over time. And we've also been releasing some new products that I'll go over in a little bit. But our primary end users are going to be researchers. That can be commercial and academic. Government entities like the USDA or Agri-Foods Canada, those sort of entities around the world. Corporate agriculture, any large agricultural company that has a research branch, and then service providers who are servicing those top 3 groups primarily. So that's kind of who our end users are. So let's talk about multispectral imagery. So this really simple diagram on the right is giving you a really basic understanding of what our camera is capturing. And generally in passive remote sensing, this is true for passive remote sensing universally, really. The sun is casting light energy onto an object, and then some of that energy is getting reflected, and the energy that's getting reflected is what our camera is picking up. So specifically in multispectral imagery, we're looking at visible and near infrared light. That light's hitting a plant canopy. Some of that light's getting absorbed by the plant to be used in photosynthesis. Some of it's getting transmitted. The data that's getting reflected is what we care about, and that's giving us an indication of the physiology of that plant canopy at that given day. So let me just explain this graph. On the y-axis, we're looking at a percentage of reflectance from 0 to 50%, and then on the x-axis, we're seeing a portion of the light spectrum. So here's the visible portion, and then we're in near infrared light over here. And inside this graph is a green line that's representing typical reflectance of a healthy plant. So if you follow that green line from left to right, it makes sense based on what you experience, in nature, right? So we follow the green line. It's got very low reflectance at blue. It increases a little bit at green, and then it drops again at red. So plants typically absorb a lot of blue and red light for photosynthetic activity. At green, they don't really absorb a whole lot of light. A lot of that gets reflected, and because it's in the visible portion of the spectrum, that's what we see when we see healthy plants typically, is we see a green plant, and that's because there's higher reflectance at green. When we get into near infrared, if a plant's healthy, it's typically going to have very high reflectance in the near infrared. So as a plant changes physiologically, whether that's due to changes in growth stages, due to stressors that may be insect related or nutrient deficiency related or drought stress related, it's going to also change physiologically, or it's going to change in terms of its reflectance profile. So any physiological change is going to impact how this reflectance looks. Typically, we see a decrease in reflectance in near infrared, and an increase in reflectance at red and blue. So one way to think about this is in the red, as a plant changes from the summertime to the fall time, you typically see changes in that color of those leaves. And that's because as those leaves start to die, they stop using red light. And so we start to see changes in those leaf color from green to yellow to red to brown. And it's because the reflectance is changing in that plant. So what we're doing with multispectral imagery is we're taking a camera, a special camera. We're pictured here as the Red Edge MX, and we're capturing discrete spectral bands along that plant's reflectance profile. So the Red Edge MX and the Altum camera, they're capturing these 5 spectral bands. So they're capturing a band at blue, at green, at red edge, and at near infrared. And what that's doing is it's gathering 5 points of reflectance data that each give us a different indicator of what's going on in that plant. And so what we can do is we can use these 5 spectral bands to create many different indices and composites that give us different bits of information about what's going on in that plant canopy. So for instance, NDVI is a very commonly used index in agriculture. It's a good indicator of biomass variability. And the way that we create NDVI is by using the spectral band at red and at near infrared. So that's how it ties into what the camera's capturing. Another pretty commonly used index is NDRE. So this is generated using red edge and near infrared. NDVI is generally going to give us an indicator of variability in biomass, whereas NDRE is more correlated with chlorophyll content. So this is just illustrating the importance of multiple spectral bands. If we just were capturing red and near infrared, we might not be getting the full picture of what's going on in that plant canopy without red edge and near infrared, which is used in generating NDRE. So another important element, in addition to the narrow spectral bands and the multiple spectral bands we're capturing, is radiometric calibration. So radiometric calibration is important because it allows us to compare accurate changes in the crop over the course of time. So probably the easiest way to think about this is if you flew a field today and it was a clear sky, the sun was shining, there wasn't a cloud in the sky, and then 2 weeks later you went to that same field and you wanted to see how the plant changed physiologically from that first flight to 2 weeks later. But the second flight was an overcast day, and so the lighting conditions have changed from the first flight to the second flight. And so to get rid of that bias that's occurring from the lighting conditions, we need to radiometrically calibrate so we can have an absolute value, reflectance value from the first flight to compare to an absolute value in the second flight. And so these two test plot images right here, data sets, this is NDRE for both of these, they were captured about 3 weeks apart. And you can see how on the scale that you see here, we call this a histogram, and it's basically showing us where certain values are occurring most frequently. And you can see a peak at this date that's probably around 0.2, whereas 3 weeks later we're seeing a peak that's closer to maybe 0.1. And so we wouldn't be able to confidently say that there was actually a shift that occurred on this scale if it wasn't for calibrating the data. Otherwise, we're just basically able to make relative comparisons on that given day, not temporal analysis. So the way that we perform a radiometric calibration is we use these two pieces of equipment. So with every multispectral sensor that Microset sells, we include a calibrated reflectance panel. There's a known reflectance value on that white square. And so before the flight and after the flight, we take a picture of that panel, and we can use that value. Actually, I think in Pix4D fields, that's automatically recognizing that panel, but Nathan can correct me if I'm wrong later in the presentation, but it's going to automatically recognize that panel. And it's also going to use this information from the light sensor mounted on top of the drone that's capturing data and writing it into the metadata of every image that's captured. So these two components combined are going to provide you with radiometric calibrated data out of Pix4D fields. So this is a kind of a nice example of the DLS2 working really well. So I kind of glossed over this a little bit in the last slide, but the DLS2, every time an image is captured, it's writing the lighting conditions from that image into the metadata of that image. And so the panel is giving us a kind of a general overview of the lighting conditions for that day. The DLS2 is seeing how changes are occurring across the field. And so this is on the left-hand side, we're seeing a field that's got some clouding artifacts in it, or clouding issues going on, and the DLS2 pretty well corrected for those clouding issues, as you see from left to right. So I think that was a pretty good success story to share about the DLS2 correcting data. So I mentioned earlier, we focus 100% on hardware development. These are the three primary sensors that we're developing currently: the Altum, the RedEdge MX, and the DLS2. So the DLS2, the light sensor, is included in both cameras, in both camera kits. The RedEdge MX is 100% just multispectral imagery, so it's capturing these 5 spectral bands. It's a lightweight camera. The imagers in this camera and the lenses are going to generate about 8 centimeters per pixel spatial resolution at 120 meters. This is the camera and the imagers and the lenses that MicaSense and the spectral bands that MicaSense has been offering since the beginning. The most recent release and kind of the new product that we're pretty excited about, and it seems like the customer base has been adopting it pretty readily, is the Altum. So this has a higher resolution imagers that are going to generate about 5 centimeters per pixel GSD at 400 feet or 120 meters. So it's got higher spatial resolution capabilities. And then it also has a thermal imager by FLIR. So this thermal imager, when you process through Pix4D, you're able to align the multispectral data with the thermal data. So it's easy to compare the thermal images that may be showing you irrigation issues, whereas and side by side with the multispectral data that's showing you biomass variability or chlorophyll content variability. So it's kind of taking agricultural remote sensing to the next step of combining thermal with multispectral. And then just to finish up before I pass over to Nathan, I just wanted to tease you with this new system that we're getting close to releasing this October. So it's a dual camera configuration, and what this is doing is it's capturing 10 spectral bands instead of 5. So we've taken the RedEdge MX and we've added 5 new spectral bands to a new version that we're calling RedEdge MX Blue, and these are going to be flown together and triggered together to capture 10 spectral bands. And these spectral bands are pretty well correlated with Sentinel and Landsat satellite data. So anyone who's wanting to make correlations between satellite and drone-based multispectral imagery is going to be interested in this. And then it just like really increases the possibilities in terms of indices and composites that can be created, because we're going from 5 spectral bands to 10. So we think that this is probably going to be pretty interesting for all of our research, commercial research and academic customers. So Nathan, I think I'll go ahead and pass it over to you.
Thanks, Drew. And thanks for that bit on multispectral imaging. That was a good introductory if anybody hasn't heard or seen any of that information before. Myself, as Jorge introduced me, I am the business development for Pix4D here in the US, and I've had the pleasure to work with Andrew for quite a while now. We met in a rice field here this spring and flew a field with the RedEdge MX as well as on the EBX platform. It was a quick flight and turned out really well. At the time, we flew it. It was actually with quite a bit of water. We fought water all spring and all summer, it seems like. But from my screen, you can see here that this flight we did actually has a little bit of water in the side here. Water was kind of encroaching as we were flying. And you can see this nice RGB that was put together from that. Now, this flight has already been generated and this data has been populated. Very simple process as far as importing the data. You would just click import. You would import your images, and then you would tell it where that directory is, and then it would just process this data. And I think we process this in the back of the truck, so you can see the trucks over here. We probably processed that in about 5 to 6 minutes after the flight, so pretty much instantly. As Drew was talking about, the calibration image was actually taken before the flight, and after the flight, the image is automatically imported with this. It's automatically processed. It asks us, is it a sunny day or a cloudy day? It was a sunny day during this flight, so I just clicked sunny day and it processed it and corrected all the data. And this is this is really important for Andrew and his crew, because obviously getting this calibrated data is really important. It also is important that it's simple and easy to do in a mechanical way. So they just take the pictures, they're automatically imported, all the reflectance values are brought in. There's a lot of stuff going on behind all the tags of all the images, and all that information is being read in seamlessly and without anybody touching that data. So this makes sure that you get very high quality data with very few mistakes. So from here I generated an NDVI. You can do so by just clicking the index generator, and it'll bring up a whole bunch of the types of indexes that are available based on what type of camera that you're using. So this camera has 5 bands, so we have quite a few of these indexes unlocked. And you can also create a custom index. So if you have something specific that you want to calculate, or a certain band that you want to isolate, you can go ahead and put that in here really easily. And then once it's generated, we end up, say I do an NDVI, you can quickly view this. This process only takes less than a minute really to process this type of data. You can see very quickly from this, and we were sitting, as I said, right over here in this driveway. You couldn't really see this field, and you really couldn't see the variability quite well. I mean, it looked pretty weak from up here, but down here on the south end, we couldn't see how nicely developed this was. And so, from there, I actually did some flight shots off of this, and I'll show you really quick what we did with the annotations. So we can annotate this data, which is really nice. From the GNDVI, I did this, and I have lots of notes on here, you'll see. So I can take notes, I can add pictures as well. So going back here, we can see where we were located. You can see the pump and the tank here, but we can go ahead, and I even took a picture of our flight where we landed. And I can go over here, but what's most interesting is being able to understand what's happening with our data, and being able to take annotations and seeing this is a good way of telling the story. So now you can see kind of what we were seeing when we were in the field. You can see that the channels had water in them. They were recently irrigated. You can see different drying patterns in the soil. You can also see the development of the canopy as it's growing. From there, we can look at a couple different spots that are kind of interesting. Whoops. We have, an overview of the field, which I think is actually a pretty nice shot. It kind of gives you this idea. Seeing, you can see that we had machines running this way. We also had tillage patterns running this way, and we have planting also going in this direction as well. And from there, we can also look at a couple different spots. We know that this area in the blue here is kind of weak, but in this red, we have a higher vigor. And you can see down here the histogram as it looks. And you can look here and see, this higher vigor and what these plants actually look like. And you can see that they're well established and they're doing well. You can also see that the soil is a bit wet behind it. Again, we can go over here and we can see this area, which is really strong, and we can actually see the double planting. So you can see how we have quite a bit of material there, and it shows up well in our map. Even here, there was an interesting spot. I think this was actually off here. This is a fallen tree that was here. So that was just something that happened to be in the picture. And, there's a lot of different things happening in the picture. We just took a few different shots, but you can see how strong the growth is down here on the south end versus the north end on the establishment of the rice. So that is very helpful in understanding and adding context to this. Again, another nice thing that you can do from here is if you like these notes, we can go here quick, and we can export a real quick PDF, which is a good tool for anything out fast in the field. We can go to this here and we can click the paper size and export the paper. And we can export that PDF report. PDF reports, you know, at some level are just a piece of paper, which is great. A lot of growers really like this, and a lot of, I mean, most of agriculture is still using paper in many cases, so emailing a PDF isn't a really big chore for many people. And in it, which is really nice, is the ability to see all these photos, to see, you know, the notes that were taken, especially from any sort of an agronomist that was in the field and working. You can also see, you know, so many different aspects of what's going on and being able to convey that information easily. So here's our PDF report. There's our overview picture. It gives us some basic stats on our field, gives us the printout of that picture, and then as we go, you can see all these different notes that we took, and you can see those pictures as they are. So I'm not going to go through all the pictures and what it looks like. I just wanted to show that that's something that you can do from the program. Another thing that's really helpful is the ability to do rapid prescriptions in the field, and this is something that I'll go over in just a second. I really wanted to show, well, I'll show this first. So we'll go through the zonation and prescription. Very simply, you just break down the field and how many zones you want to use. So maybe you want to use 5 zones. Maybe you want to use 3 zones. I think this 3 is fairly okay. We can click generate, and off of that you can have, you know, these varied areas of growth. Now we know that the growth was weak in the northeast, and we know that the growth was strong here, and this seems to be fairly accurate. I can apply this zone, and from there, if I want to check what it looks like, I can go to compare. So if I want to compare this, this is a very nice tool that we have built into the program. You can switch here and you can look at this, and you can look at the each part of this, and you can see if they actually make any sort of sense to you. And this just helps. You can also go to split screen. Again, you can make really quick looks at this. If you want to go back and finish out your zonation, say you say that that's accurate and you want to put on maybe another seeding rate, or maybe you just want to put on some sort of fertilizer of some sort, you could say maybe we're going to put 50 pounds in the area that isn't doing very well, and in the areas that are doing fairly well, we're not going to put only but maybe 10 pounds, and we'll be at 25 for the middle. And you can save this, and again, very simply, you can export this as a shape file. So we can go to our zonation, we can click shape file, and we can click export, and then we can take that to any sort of monitor, you know, that puts on any sort of variable rate applications, and this should be very, very simple to use. You know, most of these tools are all in here for, you know, anything that can be done in the field. Again, field boundaries can be loaded here. I didn't show this, but you can draw your field boundaries, or you can import shape or KML files. This is a very farmer and agronomy or agriculture friendly in many cases. You know, these shape files, KML files, are very standard across the ag industry. It's very easy, and most farmers and most agronomy, or most everybody in agronomy or using any sort of farming management platform has shape files of fields, so it's easy to import these things, and it makes the work a lot easier. This is especially helpful for people like Andrew that have, you know, hundreds and hundreds of fields to go and take care of. You can bring in the shape file, you can process it, clip it to the boundaries, because we don't want to analyze something based on, you know, what we, you know, we don't want to analyze the road versus, you know, the plant. We just want to analyze the plant material. So that's a very basic overview of Pix4D fields, but you know, I think this is a good program. It fit really well in Andrew's workflow, and I'll let him talk to you a little bit more about how that works.
All right, so moving on into kind of our workflow and how we've used Pix4D fields, and how we've used Pix4D fields and and the MicroSense cameras. So the title of this webinar I thought was great. Quality meets speed in digital agriculture. Those are really the two main things that I'm going to be looking for in any sort of UAV crop monitoring system. It needs to have high quality data to where that data is going to provide some sort of action to the farmer, but then it also needs to be fairly quick to where we can provide that actionable data in a timely manner. It does me no good to have slow software that provides data too late to my grower. So a little bit about myself. So I am the sensor operations manager here, and better known as the drone commander. That was actually the offered title, and it's just too funny not to share that with every group I talk to. But so anyways, as a sensor operations manager, I'm in charge of the technology team, where we go out and we test new technology before rolling it out to the commercial team. So we will go out and we'll test technology such as drones, sensors, such as like the mica sensor, multispectral sensors, thermal cameras. We'll test soil moisture, weather stations, just any type of technology that you think that you can implement into the field. That's what my team does. We will go through there and we will test that technology to see how applicable it is to our growers. So typically my team will fly over 20,000 acres a week. That will kind of calm down a little bit during the winter as most of the plants are in winter dormancy. But when the summer's going, we'll cover over 20,000 acres a week. So you can see why it's very important that we have a complete system that gives us very quick and very accurate results. So then moving on with that, we will always test out technology before we do any sort of large scale implementation. And with that, we have a basic 4-part setup that we look at for making a UAS, so a unmanned aerial systems. And that's really the way that you should look at it. It's a system. It's not just a drone. It's not just a sensor. It's not just a stitching software. It's a bundle. And so you really need to select parts and pieces that fit well together, and to make sure that they complement each other. And so that's what I spent a ton of my time doing here, and then also that I continue to do. But so basically, if you're looking at any sort of drone work in ag or any drone work in general, you should always start with a research goal in mind. So know what you want to do and then base everything off of that. There's far too many people that will go out and buy something and then ask, what can I do with it? I think it's a very poor way to do with it. Start with that goal in mind. What do I want to do? Then build your system out from there. So with our goals in mind, the very first thing that I always look at is the sensor. So I look at multispectral sensors, I look at RGB sensors, and then I also looked at thermal sensors. We've spent quite a lot of time testing this. I think Nathan, we actually met in a soybean field, not in a rice field, where Nathan and some other individuals from Pix4D and MicaSense came out to show me their complementary system. But basically, with these sensors, with a multispectral RGB or thermal sensor, we are looking for the basic requirements of it needs to have a adequate spatial resolution, spectral resolution, and radiometric resolution, along with along with radiometric calibration. I think, Drew, you really knocked it out of the park on explaining why that radiometric calibration is so good. And really, it boils down to, if we don't have radiometrically calibrated data, it's really hard for my team to build any sort of analytics off that and any sort of automated algorithm off of it. We really had to have really high quality radiometric calibration. And so after doing a pretty large landscape for our multispectral sensors, we selected to partner with MicaSense and run the Red Edge MXs. So then after you have that first piece, that sensor piece, it's really important to look at what kind of drone you can carry it on. To me, a drone's a tripod. It might be a $15,000 tripod, but its job is to hold that sensor in the air and get it to where it needs to take pictures. So the drone to me is always the second part of what I look for. And basically, we have looked at VTOLs, we've looked at rotor wings, and we've looked at fixed wing drones with the basic requirements of it needs to be really easy to use. I don't need something complex. I want something easy enough to where I can train up one of my guys or gals in an afternoon and have them go and collect really good data. And then also I want the ability to safely and routinely cover a minimum of 160 acres. As long as we can cover that, we can keep up with the demands and the speeds that we need to go. And so for that, we partnered with DJI multi-rotors and also with SenseFly's running the EVXs. Now, so once we decided that we were going to use those two sensors and those platforms, we started looking at what software we could actually process this with. And speed and accuracy was key here. Thinking back to when I first got into the drone agricultural sector, 5 or 6 years ago, using some of that software there, it would take, all night to process a field. I'd fly a field, I would drive the 2 hours back home, I'd put that in my computer, and I would be processing, and it would take, all night for me to get a field processed, and then I actually had to feed it into my analytics, and so it would take, on average, 3 to 4 days to actually be able to fly a field, process the data, and get a orthomosaic, and then make some sort of agronomic recommendation off that data. Well, I was very shocked and very happy to see Pix4D Fields when that was launched, because it really changed the way that we were able to get a lot of this data. So with a product like Pix4D Fields, we were able to fly that field, and then as Nathan said, we were able to process that while sitting at the field, just on the back of that tailgate. We were able to get a full map within 5 or 6 minutes. And so that was really beneficial to us. And then finally, the last piece of our system is the agronomic analytics. And this is where all the power comes from. It really does you no good to fly a field if you don't have some sort of actionable result. So that should always be your goal, is you need to give the farmer some piece that he can actually take action on. And so by using the whole system that I previously described, we're actually able to make some of our own analytics to where we can start to develop actionable results, either at the field's edge with Pix4D and some of our own processing, or within no more than 48 hours. So now let's talk about what we're actually using drones for, which is the cool part. This is the best part of my job, is actually figuring out what we can use drones for. And it was very interesting to see all the different ideas that people have came up with for using drones. And I think this has really been derived from how hardwares came down a lot in price, how multispectral sensors are cheaper, thermal sensors are cheaper, the drone chassis is cheaper, and then also a combination of that really good processing software like Pix4D Fields to where we can get it quickly. But through all that, we've seen a lot of new changes and a lot of new techniques that people are trying to do in ag. And then we've also found, it's very interesting, that really drone technology can be used throughout the whole entire growing season, all the way up from pre-plant before that tractor's even touched the ground, to all the way to harvest. That drone data is useful. And we can talk about those one by one here. So first of all, I think that drones are really good at scouting. Now, whether that is just popping up and taking a couple pictures like this, to where we're looking at some early pre-plant decisions, to where if you look at the picture on the right, we just went up and we actually looked at that field to see if it was dry enough to actually get a tractor across it to plant. Or we could take it another step further and looking at the picture on the left, where we're looking at the previous crop stand to know what kind of fertilizer recommendations we need to put down. And then going even further, if we are looking at early scouting and pre-plant decisions, we can actually use the previous drone data along with other data sources such as soils maps or yield maps, and we can actually start to make decisions on planting rates to know the amount of seed that we should put down per acre, or the amount of pounds of fertilizer we should put down per acre. They've been very useful to us in pre-plant decisions. And then also on the scouting side too, we've looked at just the overall usefulness of being able to quickly and neatly assessing the quality of the whole entire field. So if we look at this top picture, we can see kind of a yellow streak through there, and we were quickly able to see, okay, this is definitely an issue with a nitrogen application where they didn't get nitrogen down there for some reason. For some reason, that sprayer turned off, or they ran out of fertilizer. Something happened to where they didn't get nitrogen applied. And what this allows us to do is it allows us to get boots on the ground and allows us to get right there that we can actually see what the problem is. The second picture is also a nitrogen problem, where the nitrogen was actually misapplied and it burnt the crop and actually killed it. We can also use this drone technology for looking at damages in crops, such as the picture below, where we have all this corn drowned out. And this kind of information is actually very valuable to our growers to know how they should start to take action and how they can manage that crop in the future. For example, where it's drowned out, maybe we install some sort of drain tile or terrace that differently. We've also used drone scouting quite a little bit for that field side scouting or from the roadside scouting. Okay, I don't know how many of you have walked through a rice paddy before, but it's really, really miserable. You know, we're talking standing water. There's alligators in some of them, and cottonmouths, which are poisonous snakes. So it's really nice to let my employees be able to scout the field from the comfort and safety of the roadside, or by sitting on the pickup tailgate. It's really nice for them to be able to go out and fly a field and actually start to get some really up close pictures and start to determine what's going on in that field without actually have to step foot in it. And this keeps them safer and allows for a much better scouting report to the grower. And so in these pictures, we can see that this top field is a muddy field in Kansas. That's what we call gumbo clay soils, where it's just a very heavy clay soil that's going to stick to your boots, and your boots are going to weigh 20 pounds apiece. So walking across that muddy field would be very hard. Where my guys were actually just able to send up the drone, take a picture of the wheat, and we were able to determine the growth stage, which is actually what their job was supposed to be that day. Or another example is the cotton field, where we sent that drone out there and allowed to check out differences in leaf venation. So we've also done quite a little bit of work on doing stand counts and replant decisions. So basically we are letting the farmer know if he or she should actually replant their crop. This is a very big decision for most farmers. Seed is very, very expensive and will cost them a lot of money if they make the wrong decision with a replant. If they currently have a sufficient stand and they decide to replant it anyways, they're basically adding in extra money of that seed. Or on the other hand, if they think that there's an adequate amount, but there's really not enough stand count and they decide not to replant, we could have the potential for a massive yield loss. So the traditional method for doing this is a crop scout or agronomist would go out to the field. They would randomly select 15 to 20 locations. They would set out a tape measure and manually count the plants in that given area. Then they would use those 15 points as a representation of the whole entire field. Now, it's very hard to expect 15 locations to get an accurate representation of the whole entire field, so we started using drones to actually be able to do replant decisions, where we fly a super high spatial RGB drone over the whole entire field to where we can see plants that are around an inch and actually tell the farmer where he or she would need to replant. So this has been a really popular one that we're currently developing. We've also been able to use drone imagery, particularly the red edge imagery, to start making actionable decisions for growers. So what's really cool about using VIs that use red edge, near infrared is that it can see stuff in that plant that we as humans cannot see. So we as humans can only see red, green, and blue. And so there's very little that plant can actually tell us while it's getting sick. The plant will tell us, like after the symptoms have already taken hold, that there's something wrong, but it's very hard to get that first telltale sign that something's wrong. Now, by using multispectral imagery, because of that camera's ability to see in the near infrared and the red edge, we are actually able to tease out some of those problems and see some of those problems that's happening with nitrogen deficiency or drought stress. We're actually able to see that early on, and this is a prime example of this. So this was a cotton field down in the southern part of the U.S. that we were seeing kind of an interesting growth pattern in the image, to where, as you can see, closer to the pivot, so closer to the center point, we have really green and lush cotton. But then once we get out to the outside portions, we no longer see the same growth pattern. It's getting less vigorous. And what was really interesting is on the ground, we couldn't really see this change because there's such a gradual change from low-performing plants to high-performing plants. You didn't pick this up with your naked eye. But using the MicaSense imagery, we were actually able to see this, and we determined that this was 100% fixable. This was an easy problem. This was all due to pressure regulators on that irrigation pivot. We increased the pressure, and we were able to fix this problem. We've also found using a combination of RGB sensors and multispectral sensors have been really beneficial. I got these two pictures along with a short email. Actually, I think it was a text message from one of my agronomists, and he basically said, hey, we're seeing some streaking in this field, and it looks like it's an anhydrous burn, so where the nitrogen actually burnt the plant when they applied it. Could you come out and could you fly to quantify this damage? So we got out a MicaSense camera, and we flew that over the whole entire field, and we created a map to where we could actually see damages in that field. And what was really interesting is we actually picked up on damages from nitrogen burn that we didn't pick up with our naked eye. And so from that, we were able to tell the farmer, hey, I know that you're using GPS to guide your planting and to guide your nitrogen application. Because of this burn, you really ought to re-angle your fertilizer application to get this corrected. He did, and this wasn't a problem anymore. We've also used drone data to look at the nitrogen content of crops, whether that's to try to look at protein percentage in that plant, or whether that's to get an idea of what we're going to yield. This is still very much in the developmental stage, but we're looking at actually being able to look at predicting protein across fields. And then going back to the idea of that multispectral data can show you things that's happening in the field that we as humans cannot. This is probably my favorite example of this. So if you look at this top image, the RGB image, you really can't see much variation in the crop. Granted, you can see that there's definite streaks going through there that are fairly wide. That's because there are actually different varieties of wheat out there. I think there's 7 different varieties that's replicated twice here. So that's why you're seeing different colors. But you don't really see the wheat streak mosaic, which is a viral infection in that wheat from the RG picture. We really didn't even see it on foot. The full symptoms didn't show up until about 1 week after we could pick it up with the MicaSense camera. So this bottom image, where we're seeing this really dark red and almost black down in the southwest corner, that's that wheat streak mosaic that wasn't visible prior. So once again, the multispectral camera allows us to really see these problems happening in the field. We were also able to use drone imagery to start to make basic zonations to know how we should manage each portion. Now, while we do implement some really nice soil testing techniques, that's not always going to be available to most farmers. So we're trying to make measurements to where we can actually start to tell some soil characteristics from multispectral imagery, and that's showing some good promise. And then we've also been looking on using drone data to assist with yield potential. And the key word there is potential. Most people don't understand that when we make a yield estimation, most people, will try to hold you to that yield. It's really a potential. If you're trying to do yield early in the season to late, there's a lot of things that can happen. So you're looking at what that crop is actually capable of doing, or just looking to see if it can actually make it to harvest, which is what this picture's from. This was a cornfield that was really heavily drought stressed. And that farmer was basically asking us, hey, will this make it to grain harvest, or should we just go ahead and bale it? And using our own algorithms and the data that we collected from the drone, we were actually able to say only about 30 acres are actually going to make it to harvest. So therefore, the other, because it's been such a dry year, let's go ahead and bale it. Now, this greatly helped out that farmer because not only did he reduce the amount of inputs that he paid for the part that he baled, he didn't do a second round of nitrogen. He didn't have any other inputs. He was able to bale that off, sell it, but then focus inputs on that part where we had really good water holding capacity in the soil, and focus his efforts there, making sure that 30 acres made it to harvest. And then another easy thing that we can actually use drone imagery for is quantifying how much damage we actually have in our field. So these two pictures are some damage. The top one is lodging and rice, where basically a large windstorm went through there and knocked over a bunch of the rice. And depending on when this happens to a crop, it will pretty much kill the crop, and you won't be able to harvest it. So this gives us the ability to actually quantify that to where if they need to make an insurance claim, they can quantify that. Then, as I previously stated, we do sell symbiotic microbes that actually help reduce inputs of that crop. And so part of the way that we do this is we go out and we actually collect microbes from the soil by looking at areas of stress and looking for a plant that's succeeding and that's winning in that area of stress. Then we'll do we will sequence that data and actually find out what microbes make them different. Then we will make that into a sim that we're going to test on the large fields. And so as part of that, we will actually test out several fields across multiple geographies, multiple states, multiple soil types to actually test how that sim is going to perform. And so our drones are actually used for that part too, in making better sims for the producer. So with that, I'll wrap up here just with a simple conclusion. Really, when you're trying to operate a really good and large drone crop monitoring system, you really need to have 4 pieces really well established. You need to have a good sensor, you need to have a good chassis, and you need software and analytics that's going to provide you with actionable results. And that's one thing that I've been really happy with both Pix4D and with MicaSense for their support and providing me a really incredible sensor and a very awesome software project. And with that, I'll pass it back to Jorge.
Hey, Andrew, thank you so much. Let me get my screen back. Okay, so everybody, we've almost nailed it. It's 59 minutes after the hour. Drew, Nathan, and Andrew, thank you so much for your time. I think I can speak for everybody on the audience. It was very interesting to see the technology, to hear about the behind the scenes on the cameras, and then also, Andrew, all this put together in a commercial context was beautiful. I've been answering some of the questions that came through the chat, but we have a few standing questions that I would like to ask to you guys. So maybe I can start with one question for MicaSense, Drew. one of our attendees was wondering if cameras can be integrated with other platforms than DJI drones. You want to take this one?
Yeah, sure. Yeah, absolutely. That's the short answer. We have many different partners who are UAV manufacturers, and you know, it just depends on what you're looking for. If you're looking for a multi-copter or a fixed wing or a VTOL fixed wing, we've got quite a diverse set of integrator partners. So feel free to reach out with more questions on that topic.
Thank you, Drew. I'm gonna go, and I know this is something that Nathan is waiting for. One of the attendees was wondering, does Pix4D Fields process Altum datasets? Nathan, do you have something to say or show?
Yes, if you have something to share, or if you can let me share the screen, I can show it. I was hoping somebody would ask.
You're all set.
Okay, so I was just ready for you. Real quick, I can just showcase a data set that we processed from the Altum. This was of a lettuce field, and you can quickly see that the NDVI is here. We have the NDRE, and we also have a thermal data set processed of this field, which I understand was being irrigated at the time of the flight. So you can quickly see that it was colder on one side than the other, and the water was flowing to the north in this photo. So you can see really quickly the data that was processed and how well it looks and how easy it was to pull this information up. But yes, we can process that data.
Thank you, Nathan. Let me go back. I want to be Solomonic with all the questions. So, Andrew, we have one question for you. Do you believe drones can impact sustainable ag practices?
Yeah, I think most definitely they can, and that's something that we're actually looking at in the Terraton project, looking at actually to see if drones can be used to quantify the amount of organic matter or the amount of carbon in the soil. So that's one very simple way. But then too, with these practices that I've already talked about making nitrogen recommendations or something like that, we would also be making an impact on improving the sustainability of those agricultural practices. But, you know, by reducing the amount of total nitrogen applied, we can reduce nitrogen runoff and control a lot of those efforts to where we can become much more sustainable by using these tools.
Thank you, Andrew. We have a bunch of questions that people are asking right now, and I'm gonna try to pick some of them. If you see that I didn't get to answer your question, we will answer to you offline later on. We have TFM Solutions saying that they've seen a lot of questions and use cases about nitrogen, and they were wondering if there are other relations to phosphorus, potassium, calcium, magnesium, sulfur, or any other micronutrient. Anybody wants to pick up this question?
From my end, I can speak a little bit. So, you know, obviously, you know, sulfur, I mean, speaking from corn, because that's where I operate a lot from, you know, deficiencies in nitrogen oftentimes look like sulfur deficiencies, or sulfur deficiencies look like nitrogen deficiencies. So in some cases, yes, you do need to identify what the limiting nutrient is in the problem. Oftentimes issues show up in your index analysis that you may not understand. This is where Andrew comes in and his team, you know, taking soil tissue samples, or soil samples and tissue samples, you know, to narrow down what that issue specifically is. It totally depends on the stage of the crop, the type of crop, when the picture was taken, and how it was, you know, all those things in context is what helps solve those issues. So fertility, yes, on many different limitations that exist. It just takes the know-how to use the agronomy and apply it when that photo was taken, I guess.
Thank you, Nathan. We have Alexander Enns. He's wondering, can these technologies also be used in forests? Do we have any example? I'm happy to take that question. So normally we talk about agriculture as a super industry. There are a forestry on its own is a big industry that we do not address as much as we want to, and the answer is yes. There is tons of applications of multispectral data for forest, and I believe in the past we had some use cases, but normally if you have applications or you are using already this technology in forestry, please feel free to reach out to us, because we are always looking for use cases that we can highlight. Okay. Then we had another question from Michael Taylor. He was wondering, they have a MicaSense MX and a FLIR Duo Pro. Can they process the information like what we've seen in Altum? I'll take this question as well. In this case, the answer is not for now. Altum is very unique in the sense that it all comes as a rig, so that we can use information from one band to correlate the position of the thermal. Thermal has fewer features on the images that makes it harder to process standalone, but we're definitely working towards supporting other sorts of thermal data. I have one question for MicaSense that I think is going to be also interesting. There's a customer wondering how fast can you fly with a MicaSense camera? Andrew, maybe Drew, can you take this question?
Yeah, sure. It all depends on, so it's all based on the triggering speed of the camera and also the requirement for overlap in order to get a good data set. So MicaSense recommends, and Pix4D probably does too, that you capture 75% front lap and side lap to get a good orthomosaic. And so the red edge camera is going to trigger maximum probably 1 image per second. That's as fast as it can write the images onto the SD card. And then the Altum is going to be a little slower than that, probably 1.5 to 1.75 seconds. So that's the speed of the camera. And then like as you get closer to the ground, that overlap requirement doesn't change. But the drone, typically if you're on a fixed wing, especially, the drone's going to be flying pretty fast. So yeah, the triggering speed plays into the overlap requirement. It's all kind of works together in order to get a good data set.
Thank you, Drew. And I will add to that it's important to also recognize that MicaSense cameras all have global shutters, which makes image distortion at higher speeds minimal, which makes our life so much easier. So thank you for that, MicaSense. I'm gonna address 2 more questions that I thought were interesting. Someone was asking if Pix4D feels needs of the internet to work. And the answer is no. Pix4D Fields was designed with farm managers and agronomists that are in the field in mind. And in that case, we assume that, yeah, bandwidth is not gonna be there. So everything is running locally. All the maps that you've seen can be generated on a standard computer within minutes, so that, as Andrew also said, you can go ahead and start connecting that multispectral data with what's actually happening on the field. Then there were also a couple questions from some customers that I also want to address with regards to whether or what's the difference in between Pix4D Fields and Pix4D Mapper. So Pix4D Mapper is the product for drone photogrammetry. We generate very dense point clouds that then correlate with the amount of details on the DSM or the 3D meshes that we generate. Pix4D Fields is designed for agriculture, and we focused on being able to generate 2D maps like orthomosaics and index maps that then are converted into other layers like zonations and prescriptions. What is very interesting to know is that the same radiometric correction power that Pix4D has been working on for the past 3 years is available on Pix4D Fields, which it's a huge advantage because you must trust your data. You need to be able to compare it over time in order to drive meaningful decisions. Okay, so we went 10 minutes over the hour, and I see now we have tens of questions coming through that unfortunately I won't be able to answer live, but we will take them all and we will answer them privately. It's impressive that we still have 100 people after the hour with us. So thank you very much from the Pix4D team. We've enjoyed this very much, and we hope to see you soon. Have a good day. Bye now.